Hello friends, I welcome everyone in this video lecture. So our today's topic is from quantum theory. So in last lecture from quantum theory we studied de Broglie's hypothesis. So now in this lecture we will study quantum theory, Heisenberg's uncertainty principle. So Heisenberg's uncertainty principle is based upon uh, totally quantum, not by classical mechanics or Bohr's theory, which you have studied in your last lecture. So, according to classical mechanics and Bohr's theory, exact and simultaneous determination of both position as well as momentum of any moving body is possible, which we have seen just by taking the example of a car. In last lecture we have discussed it. But when we consider a microscopic particle, that means which we can't see with our naked eyes, but for microscopic particles such as electron, it is not possible to detect the position and velocity, that is nothing but momentum, because momentum is nothing but mass into velocity. So it is not possible to detect the position and momentum accurately and simultaneously at any time, because it has a wave as well as particle nature. म्हणजे जर आपण मराठीमध्ये बघितलं तर मायक्रोस्कोपिक पार्टिकल जर असेल तर त्या पार्टिकलसाठी आपण एकाच वेळी त्याची पोझिशन आणि त्याचा मोमेंटम हे एकत्रितरित्या सांगू शकत नाही किंवा आपण डिटेक्ट करू शकत नाही. सो ऑन द बेसिस ऑफ दिस टू सायंटिस्ट हायझनबर्ग gave one principle, and after that it is known to be Heisenberg's uncertainty principle. So to explain this behavior, German scientist Werner Heisenberg stated that simultaneous and accurate determination of position and velocity, that is nothing but momentum, of a microscopic particle such as electron is impossible. म्हणजे ॲट द सेम टाइम पोझिशन आणि व्हेलॉसिटी किंवा मोमेंटम आपण एकत्रितरित्या कधीही सांगू शकत नाही. But this is true for the microscopic particle only, as like photon, electron, neutron. You may consider any microscopic particle. So in screen you can see that how can we tell the speed of a moving electron. Suppose there is one moving electron, and if we are bombarding a photon on it, you can see in diagram here. So this one is the electron and this one is photon, just in the form of wave. It is colliding on the surface of electron. So after collision occur, that time photon change its wavelength. That means when it was going to incident on the surface of electron, so that time it has a different wavelength, and when it will collide and change the position, that time photon also changes its wavelength and electron changes its route, that is nothing but its velocity changes. You can see here, this was the original position, but now it is in the below direction, it is showing that. So electron changes its velocity. So in this way we can predict that at the same time position and velocity is not possible for any microscopic particle. Now how the Heisenberg derive or Heisenberg principle can be stated in mathematical form. Suppose delta x, that is the for position, x is for position, and delta px is for momentum. So that is delta is for uncertainty. So uncertainty in position into uncertainty in momentum is always greater than or equal to Planck's constant. Or mathematically you can write it, delta x into delta px is greater than or equal to h upon 4 pi, where delta x is uncertainty in position and delta px is uncertainty in momentum. Hence Heisenberg principle also stated as it is the product of, you can see here there is a multiplication symbol, so it is the product of uncertainty in position and uncertainty in momentum, that is nothing but also velocity. So it's always greater than or equal to, you can see here in screen, is always greater than or equal to Planck's constant h or h upon 4 pi. So if we measure the position of a microscopic particle precisely, now we consider that जर का आपण असं ठरवलं की आपण या दोन गोष्टीपैकी एक गोष्ट जर आपण accurately determine केली, suppose if we measure the position of microscopic particle as like electron precisely or accurately, that is if delta x is a very small, then uncertainty in momentum increases and vice versa. म्हणजे एक क्वांटिटी जर प्रिसाइज आणि अॅक्युरेट असेल तर दुसरी असणार नाही, दुसरी अॅक्युरेट आणि प्रिसाइज असेल तर पहिली असणार नाही. दॅट इज द वाइस वर्सा. सो हाऊ वी कॅन स्टेट दॅट मोर प्रिसाइज इज द पोझिशन. यू कॅन सी इन दिस स्क्वेअर, मोर प्रिसाइज इज द पोझिशन, दॅट टाइम लेस अॅक्युरेट इज मोमेंटम. म्हणजे मोमेंटम मध्ये अॅक्युरेसी असणार नाही जर का तुमच्या पोझिशन मध्ये अॅक्युरेसी असेल तर, किंवा जर मोमेंटम तुमचा अॅक्युरेट असेल तर पोझिशन कधीही अॅक्युरेट असू शकत नाही. That will be at the same time, remember. So if you take one example, if there is any object of mass m and it is moving with a velocity v, you can see here in screen, that time, so mass is known, velocity is also known, that time momentum, because it is mass into velocity, so both the quantities in multiplication, so momentum is fixed. Now momentum is known, that is object having mass m and it is moving with the velocity v, which are known to us, then its momentum is also known or it is fixed. Now what will be the error in momentum? That is delta p. At the same time, error in position, it is delta x. Now we are saying that momentum is fixed or known, that means its error is 0. So when delta p is 0, you can see in this screenshot of this image, so delta p into delta x is greater than or equal to h upon 4 pi. So this is the Heisenberg's principle. Now when we have to calculate uncertainty in position, that time delta x is greater than or equal to h upon 4 pi into delta p. हा delta p तो गुणाकारात असेल, तो राईट हँड साइडला गेल्यानंतर भागाकारामध्ये जाईल. So it is 4 pi into delta p. Now we are saying that delta p is equal to 0. Why delta p is equal to 0? Uncertainty in momentum is 0, because this quantity is known, so its error is no doubt 0, because both are fixed, both the values we know, that mass as well as velocity, so momentum is known, so error is 0. So when we put up delta p is equal to 0, then what equation becomes here? Delta x is greater than or equal to h upon 4 pi into 0. So whole quantity becomes 0 and h by 0 is infinity. So delta x is going towards infinity. Means error in position is infinite. Now infinite, you can imagine that if error is infinite means you cannot predict its value. Remember, so error in position of object is infinite. So from this example we can understand the Heisenberg's uncertainty principle. Now on the basis of this Heisenberg's uncertainty principle, there are some numericals which may be asked in different types of competitive exam, as like MSc entrance or any other MPSc UPSC like exams. So we will see that numerical. So first numerical is here. So a golf ball has a mass of 40 gram and speed of 45 meter per second. If the speed can be measured with an accuracy of 2%, then calculate uncertainty in position. म्हणजे आपल्याला काय दिलेलं आहे, त्या बॉलचं मास दिलेलं आहे, वेलॉसिटी म्हणजे स्पीड दिलेला आहे आणि स्पीडची अॅक्युरेसी सांगितलेली आहे 2% अॅक्युरेट आहे. देन कॅल्क्युलेट पोझिशन अनसर्टन्टी. दॅट मीन्स वी हॅव टू कॅल्क्युलेट डेल्टा एक्स. So we can write, given that mass, that is 40 gram, convert it into SI unit, so it is 40 upon 1000, it is 0.04 kilogram. Speed 45 meter per second, it is already in SI unit. So now 2%, that means out of 100 it is 2, so it is delta V by 45 into 100. That time delta V is equal to 2 into 45 upon 100, that is nothing but percentage, you will get 90 upon 100, that is 0.9 meter per second. So by using uncertainty principle, you can use delta x into delta V is greater than or equal to h upon 4 pi m. Just it is rearranged, remember, because mass into velocity is nothing but momentum. So you can write same equation, that is the Heisenberg's principle. So put up the value, delta x into delta V is 0.9 greater than or equal to the value of Planck's constant 6.626 or 5 into 10 raised to minus 34 upon 4 into pi value 3.14 or 22 by 7, and put up the value for mass. It is 0.04. So we will calculate. After calculation you will get the delta x value. So that is nothing but uncertainty in position. So in this way you can solve this numerical. So second example based on this Heisenberg's uncertainty principle. So in microscope, using suitable photon employed to locate an electron in uncertainty of distance of 0.1 degree angstrom. What is the uncertainty in velocity? So you have given that uncertainty in position. So what is the uncertainty in velocity you have asked. That means आता आपण जर बघितलं तर जे इक्वेशन आहे हायझनबर्गचं ते डेल्टा एक्स इंटू डेल्टा पी एक्स आहे, पण डेल्टा पी ला आपण रिअरेंज करू शकतो. त्या ठिकाणी तुम्ही मास इंटू व्हेलॉसिटी हे सूत्र वापरून आपल्याला ते एक्झाम्पल सोडवता येईल. सो गिवन दॅट अनसर्टन्टी ऑफ डिस्टन्स इट इज 0.1 degree angstrom, convert it into SI, so that is 0.1 into 10 raised to minus 10 meter, and you have to calculate uncertainty in velocity. So delta V you have to calculate. So use formula delta x into delta px is greater than or equal to h upon 4 pi. That is delta x into, for delta px you can substitute here m into delta v because mass is known. So uncertainty will be in velocity is greater than or equal to h upon 4 pi. So we can rearrange above equation. So delta x into delta m and delta v, m will be in multiplication. Now it goes towards the right hand side. So now it is in dividation. So 4 pi m. Put up the values and calculate for delta V. So you will get value, substitute all the values and see the value for delta V. It is greater than or equal to, after calculation you will get 0.0526 into 10 raised to 8, or also you can write 5.26 into 10 raised to 6 meter per second. So that is the uncertainty in velocity. So such kind of numericals may be asked in different exams. So in this way you can prepare. So this lecture will be definitely helpful for you. So the remaining or next part from this quantum theory we will see in our next video lecture. Thank you.